Hi guys, today in this lesson we are going to look at regression. So I'm going to select the question number 5 from AQA Mathematics Unit Statistics 1B, Friday the 14th January 2011 paper. So in this question it says that Craig uses his car to travel regularly from his home to the area hospital for treatment. He leaves home at X minutes after 7:30 a.m. and then takes Y minutes to arrive at the hospital's reception desk. He leaves home at 0 minute after 7:30 in this case, 5 minutes after 7:35, 7:40, 7:45, so on and so forth. This X means how many minutes after 7:30 he left the home. And the Y is the response variable. It says that how many minutes it took for him to reach the hospital. If he left at 7:30, it will take about 31 minutes. If he left at 7:35, it will take about 42 minutes. So depending on the traffic situation, so the time it took him to reach the hospital varies. Let's see part A of the question. Part A. Explain why the time taken by Craig between leaving home and arriving at the hospital's reception desk is the response variable. So as we have seen just now, the value of y is the response to the value of x. So therefore our answer is A. Time taken to arrive at the hospital depends on the leaving time due to traffic conditions. Therefore y is the response variable. So depending on the value of x, it responds. Y will respond to that value. So it has a dependency to the value of x. That's the answer to part A. So let's see part B. Calculate the equation of the least squares regression line y and on x, writing your answer in the form y equal to a plus bx. What does this mean? Basically, regression line is something you plot the value of x versus y, and for example 0, 31, 5, 42, 10, 32, like that. You can plot these values in a graph, and then you join these values. So just draw a line to best fit the points. So this equation that can fit in with the least squares errors is called y equal to a plus bx. So to get this line, we have several methods, but in this case we are going to use the calculator method. So we'll use a calculator to find the values of a and b. So first we need to set the calculator to the statistics mode. We'll bring the calculator out here. So it depends on the type of calculator that you have, but in this case I have this model, and then here what I do is I will select the statistics mode number 6, and then a regression mode. So we can, when you go to number 2, y equal to a plus bx, so we can see the values x and y. So you need to figure out how to go into a statistics mode, a regression mode, in which you have to enter the values of x and y, and then once you enter those values, you can calculate and you can obtain a and b using the calculator functions. It's totally allowed in your exam. So what we try to do now is to enter these values into this. So we have to be careful to enter all these values in the correct order. So first we'll enter the values in x values. 0, enter 5, enter 10, enter 15, enter 20, enter 25, enter 30, enter 35, enter 40, enter 45, enter 50, enter. So these are the 11 values. Please note that there are 11 values actually. Let's calculate again. So now we go up again to enter the y values. So so please note that always try to enter in the corresponding order. 0, 31, 31, enter 5, 42, 42. Please be careful here, otherwise if you enter wrongly you might not get the answer. 32, 15, 58, 20, 47, 25, 56, 30, 79, 35, 68, 40, 89, 45, 95, 50, 85. Okay, so if you have entered correctly, you should get 11 as the last line. So you have 11, all 11 values in here. And now is to get the value of the parameters a and b. So you just go to the mode option and the regression calculation 4. So it will give the value. In this case, if you look carefully, I'll just expand the picture here. These are the values that you get. So if I get the values on your on the screen, yeah, these are the values that you get. A is equal to 29.95, b is equal to 1.282. So that means I can write y equal to, so we can approximate this 29 to approximate to 30. 30 plus b is 1.282, 1.282x. This is our regression line using the least squares regression method. So please practice how to enter these values in the calculator in this particular case. Okay, so that's the part B. So let's see part C. In this part, it says that on a particular day, Craig needs to arrive at the hospital's reception desk no later than 9 a.m. He leaves home at 7:45 a.m. So the conditions given: he leaves home at 7:45 a.m. He wants to reach the hospital at 9 a.m. Estimate the number of minutes before 9 a.m. that Craig will arrive at the hospital's reception desk. Give your answer to the nearest minute. So it's the nearest minutes. So in this case 7:45 means, so we have 7:45, so we took the base as 7:30. So how many minutes after 7:30? It is 15 minutes. So that means our value of x is equal to 15 minutes. So he leaves the home when x value is 15. So what we need to find out is how many minutes that it might take to reach the hospital. We need to find the value of y. That means y 15. So we have the equation 30 plus 1.282 x. So we can put the value of x equal to 15. 1.282 times 15. That means he will reach the hospital so at 49.23, approximately 49 minutes. So it will take 49 minutes to reach the hospital. But the question in this case, the actual answer should be how many minutes before 9 a.m. So he left at 7:45. It took 49 minutes. So that means he will reach the hospital at 8:34 a.m. So what is the time difference? 9 a.m. minus 8:34 is the answer. That means he reaches the hospital at 8:34. So that means how many minutes before 9 is 9 minus 8:34 is equal to 26 minutes before 9 a.m. That is the answer. So 26 minutes before 9 a.m. is the answer. Let's go to the last question. Part D, part 1. So it is a very straightforward calculation. They're asking us to calculate the value of y. X is given as 85. What is the value of y? That means y 85 is equal to x is 30 plus 1.282 x. So if substitute the value 85 for x, 82 times 85, which is equal to, this is the calculator to simplify this one, you will get 138.97, approximately 139 minutes. So this is the time that he will take if he left when x equal to 85. So this is the case where 7:30 plus 85. So if we add 85 is around 35:55 is 8:55. So that means if he left home at 8:55 a.m., how many minutes it took? So 139 minutes is a very long time. That means he left the home at 8:55, then it took about 139 minutes to reach the hospital. So there is a problem here. So that's what the question number 2 is asking. So give one statistical reason and one reason based on the context of this question as to why your estimate in part D1 is unlikely to be realistic. As we saw, it is a very big number. It's about 2 hours time it took to reach the hospital. Statistically, what is the problem? Because we only calculate the estimate, use the table from 0 to 50. The value is value 85. That means x equal to 85. The value x equal to 85 is outside the region considered. So it's basically, it is an extrapolation. Therefore it may not be accurate. So that is the reason 1. Then the second reason, basically you can see the time 8:55 is AM can be well after peak traffic time. So therefore it is not, therefore 139 minutes travel time at this time, this traffic condition may not be realistic. So that is our second reason. So statistically it is away out of the region that we considered. In general, according to the context of this, because we only considered from 0 to 50. So when it was 0, about 31 minutes it took. When it was 50, it is about 85. So this point is actually around here. So it gives a number like 139 minutes. So it is well above the very large number than the numbers that we got here. So it can be very unrealistic. Thank you.